So what about the Earth? We've used the Earth as our prototype example of both the water and carbon cycles working smoothly. But let's look more closely at what's going on here. The first thing to look at is where most of the Earth's carbon is. There's no reason to expect us to have any less carbon than Venus, and in fact we do have about the same amount. However, while the carbon on Venus is mostly in its atmosphere, on Earth this is mostly tied up in rocks, especially a class of rocks known as carbonates. Limestone and chalk, like these limestone cliffs on the California coast, are common examples of these sorts of carbonate rocks, and we see lots of them in the Earth's crust. Here's a short making sense table to help you put together what we've just covered on cycles in terrestrial planet atmospheres. Now we can fill in the last column in our table of worlds in our solar system. Review the material we've covered to fill in the description of the atmospheres. You should say what the 1 or 2 most important gases are in the atmosphere and how they formed. Also, give a qualitative description of whether the atmosphere is thick, moderate, thin, or virtually non-existent. You may have to look up information in your textbook to fill in some of these.
We know that the carbon cycle is keeping the Earth's climate fundamentally stable. However, it's important to remember that a negative feedback system isn't stable because it never leaves equilibrium. It's stable because it eventually returns to equilibrium after it's been pushed away from it. In the last couple of centuries, our climate has been pushed away from that equilibrium. We've already seen that the temperature of the Earth's surface is closely connected with the amount of carbon dioxide in the atmosphere. In the last couple of centuries, the amount of carbon dioxide in our atmosphere has been steadily rising, going up some 40% in the last 250 years. The solid line on this chart shows the amount of carbon in the atmosphere since the late 19th century, while the lines of the histogram show the average global temperature. As you can see, the temperature has been rising along with the carbon dioxide. This is also the period of time when human industrialization has been occurring, first in Europe and North America, and later over much of the globe. Many industrial processes contribute to carbon dioxide in the atmosphere. Burning coal is a very effective way to add carbon, as is burning many other fossil fuels. Even making cement can add carbon to the atmosphere, since cement is made largely from limestone. As a result, humans are now the major contributors to the amount of carbon being added to the atmosphere. The effects of this on the Earth's temperature are becoming more noticeable. Already, the Earth is warmer than it's been in thousands of years, and it's likely that the temperature is still catching up with the amount of carbon dioxide in the air.
Before we look at the likely effects of this warming, let's talk about a few of the common myths that get thrown around regarding this topic. First, some folks argue that the effects we're seeing have nothing to do with the carbon humans put in the atmosphere, and instead it's all caused by changes in the sun's luminosity. It's certainly true that small changes in the sun's brightness can have an important effect on our climate, and there probably have been historical changes in Earth's temperature tied to the sun. However, that simply doesn't work here. We have very good measurements of the amount of energy the sun is producing, and we can determine just how big an effect this can have on our climate. Simply put, the sun's brightness hasn't been changing that much, so it can't be responsible for the warming we've been seeing, especially in the last 50 years. The only way we can make sense of how warm the Earth is getting is to include the effects of all that carbon we've been adding to our atmosphere. This is what accounts for the additional heating that explains how warm our planet is getting. What about in the past? Wasn't it warmer in the Middle Ages? Actually, no, it wasn't. In some places like Northern Europe, the average temperature was warmer 1,000 years ago than it is now. However, averaged over the globe, current temperatures are warmer and still going up. Every time there's a big volcanic eruption, you're likely to hear somebody claim that this volcano is putting out more carbon dioxide than humans ever have. This one is flat out wrong. In fact, when you compare the carbon output from all of the volcanoes on the globe to what humans are producing, the volcanoes barely register. As you see on this chart, human carbon output is almost 2 orders of magnitude larger than volcanic carbon production. That's 100 times. The fact is, on a global scale, we are very good producers of atmospheric carbon.
So how will the Earth's climate change as a result of global warming? First off, we're not going to turn into Venus. There is no chance that humans can put most of the global carbon into the atmosphere, and eventually the carbon cycle will succeed in pushing us back to an equilibrium. However, remember that cycling carbon down into the deep ocean takes thousands of years. So on a human timescale, it's going to take a while for things to return to normal, even if we were to stop adding carbon dioxide to the atmosphere today. So what are some of the things that can happen as the planet gets warmer? First, one thing most people have heard about is higher sea levels. This happens both because melting ice on the continents flows into the oceans and because warmer water expands. We're seeing some signs of both of these already happening. We don't currently know how far this could go. It depends on how much of the big reservoirs of ice in Greenland and Antarctica melt. Even the most optimistic forecasts now suggest a large fraction of a meter rise in sea level in the next century, and most are expecting more than that. Much of the world's population lives very close to the ocean shores, and higher sea levels mean higher storm and tidal surges that can be very threatening to people living on the coast. Another effect of a warmer planet is more big storms. Remember that large storms like hurricanes get much of their energy from convection over warm bodies of water. The warmer the water gets, the more energy is available to power large storms like this one. As the planet warms, wind patterns will shift, causing some places to get wetter while others get much drier. Most predictions suggest that here in the southwestern U.S., the trend will be toward a drier climate. The last time global temperatures were even close to what we see now, there was a nearly 2-century drought in this part of the world, so it wouldn't be a surprise if the same thing happened again. As temperature and rainfall patterns change, so will the locations where plants and animals live, including the ones we rely on for food. These shifts can have a huge effect on global food supplies and ecosystems. These are not challenges for the distant future. They are effects that are already starting to be observed, and it's expected that in the next several decades they'll become ever more important in all of our lives.
Since 1988, the key body that has been compiling global information on the Earth's climate has been the Intergovernmental Panel on Climate Change, or IPCC. IPCC was formed by the United Nations to monitor and report to member nations on the state of the Earth's climate. A large cross-section of experts from around the world reviews the scientific literature, as well as reports from individual governments and industries, to give a complete picture of the state of the global climate. Every few years, the IPCC produces a lengthy report on how the Earth's climate is changing, what the causes are, and the impact of these changes both now and into the future. While the full report is both long and quite technical, the panel also produces a summary for policymakers. This summary provides a non-technical overview of the panel's findings. The link below gives the most recent summary. There are several major conclusions that have been a consistent part of the last several IPCC reports, and the evidence supporting them has only been getting stronger. These include the observations that over recent decades the Earth's atmosphere and oceans have been warming, the amount of snow and ice is decreasing, the sea level is getting higher, the amount of greenhouse gases in the atmosphere have increased, and finally that human activity is the primary cause of these changes. In this assignment, you should download and read over the latest IPCC Summary for Policymakers and answer these questions about the report.